So normally vitamin C is synthesized from glucose in plants and the livers of most animals, except humans and a handful of other animal species. And this is due to random genetic mutations that have occurred over our evolution that have resulted in a key enzyme in the biosynthetic pathway being knocked out. So we can no longer make vitamin C or synthesize it in our livers. So what this means is that vitamin C is now vital for life, and we must get it through our diet in order to survive. And the best sources of vitamin C are fresh fruit and vegetables. Vitamin C has numerous functions in the body. It's a cofactor for a family of metalloenzymes which have numerous important biosynthetic and regulatory roles in the body. For example, it's required for collagen protein structure, cellular energy production, hormone and neurotransmitter synthesis, and metabolic regulation. And recent research is indicating a role for vitamin C in epigenetic regulation. And this is a very exciting new area of research because it's indicating that vitamin C can help up and down regulate thousands of genes in our bodies. So as Emily mentioned, Linus Pauling is well known for his work around vitamin C and cancer, having published the popular book Cancer and Vitamin C in the late 1970s. In the mid-1970s, he carried out a study in 100 terminal cancer patients who'd been treated with 10 grams a day of intravenous vitamin C for at least 10 days, and then 10 grams a day of oral vitamin C thereafter. And he reported that the patients who received vitamin C had much better survival than the control patients who didn't receive any vitamin C. And this was true for all cancer types, but in particular colon and breast cancer. So after he published this study, doctors at the Mayo Clinic in Arizona decided to carry out a couple of clinical trials to see if they could reproduce these findings. So in these studies, patients with advanced cancer were treated with 10 grams a day of oral vitamin C or a placebo tablet, which contains no vitamin C. In both of these studies, there was no differences in survival between the vitamin C and the placebo group. But has anyone noticed the differences between these studies and the original Pauling study? These studies used oral vitamin C only. The original Pauling study used intravenous vitamin C initially, followed by oral. So this is where a lot of the controversy around the use of vitamin C in cancer has come from. A lack of understanding of the differences between oral and intravenous vitamin C, because we now know there are large differences between the two. So this figure shows you the blood levels of vitamin C after oral or intravenous vitamin administration. You can see after oral administration, you just get this little blip in your blood. Can't get my mouse. Whereas intravenous vitamin C bypasses the regulated intestinal uptake of oral vitamin C, which means you can get much higher blood levels following intravenous administration. However, you can see that this high peak is still quite transient, and that's because vitamin C is water soluble, and so any excess that the body doesn't need is excreted quite rapidly by the kidneys. So it has a half-life in blood of only less than 2 hours. Anyway, to put this into perspective, an infusion bag of vitamin C, which typically contains about 70 grams of vitamin C for patients with cancer these days, is equivalent to 1,000 oranges, and that's why it needs to be administered intravenously. High-dose intravenous vitamin C is likely required or facilitates penetration of the vitamin into the core of solid tumours. So we've recently shown that the core of colorectal tumours is very low in vitamin C, as you can see by this red area here. Following intravenous vitamin C administration to these patients, you can see much higher levels of vitamin C in the tumour, and this likely facilitates its anti-cancer activities. Other research has shown that People who have higher vitamin C levels in their tumours have much better survival than people who have low levels of vitamin C in their tumours. And this data here is from patients with breast cancer, but similar trends are also observed with patients with colorectal cancer. So Jenny Driscoll, who's on our panel, has had many years' experience administering intravenous vitamin C to patients with cancer, and she's also been involved with a number of clinical trials, so she'll be able to answer many of your questions around these areas. So what is the connection between vitamin C and respiratory infection? It turns out that serious respiratory infections such as pneumonia are a major complication of the vitamin C deficiency disease scurvy, and pneumonia is one of the major causes of death for people with scurvy. So this indicates a strong link between vitamin C insufficiency and infection. And we now know that vitamin C has numerous roles that support healthy immune function, including improving the ability of white blood cells to eliminate pathogens from the body. Once again, it was Linus Pauling who stimulated an interest in the use of vitamin C for respiratory infections. You can see that not long after Pauling published his book, Vitamin C and the Common Cold, in the early 1970s, there was a huge upsurge in clinical trials investigating the use of vitamin C in the common cold. This figure shows vitamin C levels in patients with severe infections such as pneumonia and sepsis, shown in the orange here. You can see their vitamin C levels are much lower than community dwelling cohorts, which are shown in the green bars. And if the patients go on to develop severe sepsis and end up in the intensive care unit, their levels are the lowest of all, with many in the deficiency range. Critically ill patients also have much higher requirements for vitamin C than the general population. So normally 300 milligrams a day of vitamin C would be more than enough to saturate the blood of a healthy person. However, 10 times this amount, or 3 grams a day, is required to saturate the blood of critically ill people. And this is equivalent to 40 oranges a day. And so this is why intravenous route is often chosen for these patients as well. So what about vitamin C and COVID? So the World Health Organization has highlighted vitamin C as a potential adjunctive therapy with biologic plausibility for the patients with severe COVID-19. So sepsis is a major complication of severe COVID, and this recent clinical trial carried out by Dr. Fowler has shown that septic patients who receive intravenous vitamin C have significantly decreased mortality compared to the patients who receive placebo. And he can talk more about this trial in a minute. Another recent trial carried out in Wuhan, China, in patients with severe COVID has shown that the patients in the high-dose intravenous vitamin C group also had significantly lower mortality than those in the placebo group. And there are now numerous trials running up and running around the world investigating vitamin C use for COVID-19. And Dr. Fowler is an experienced intensive care physician, and he'll be able to answer any questions you have about administration of intravenous vitamin C to patients with sepsis and COVID-19. So with respect to prevention of disease, you can see from this figure that there are a number of diseases that can be partially or almost fully avoided by healthy diet and lifestyle. These include colon cancer, stroke, coronary heart disease, type 2 diabetes. And this is why the US government now recommends that half your plate should be fruit and vegetables. And this is because they contain numerous healthy nutrients such as vitamin C. With regard to vitamin C and diabetes, we found that people with both pre-diabetes and diabetes, a much higher proportion of them have inadequate vitamin C status, which is shown by these yellow, orange, and red bars. And this was despite them having a similar dietary intake of the vitamin as the healthy controls. So what this means is that the elevated oxidative stress and inflammation that's observed in diabetes is depleting the vitamin C levels in these people. And we know that diabetes is a major risk factor for cardiovascular disease. And there have been a number of large epidemiological studies that have shown that higher levels of vitamin C are associated with lower mortality from cardiovascular disease. And this figure just shows data from a large study of 20,000 British adults. The people who had the highest levels of vitamin C in their blood, shown here, had a 60% decreased risk of mortality from cardiovascular disease compared to the people who had the lowest levels of vitamin C in their blood. Now, this trend could just indicate vitamin C is acting as a marker for a healthy diet, but it does also have a lot of functions that help support healthy cardiovascular functioning. And Meret Traber has recently published a review around the roles of vitamin C and E in metabolic syndrome, which is a major risk factor for both diabetes and cardiovascular disease. So she'll be able to answer any questions you may have around this. And now I'm going to hand back to Alex, who will introduce the speakers in more detail. Thanks, Alex.